In this part, we'll cover the issue how to prepare 2D imaging as a base for 3D acquisition. First, let me explain the advantages of using a volume probe. From the appearance, it looks less handy, but in fact, its bigger size assures the proper stability of the probe on the patient's abdomen, what enhances the precision of our 2D scan. The edges of the volume probe are more gentle, so some of the difficult maneuvers are better tolerated by the patient. The third important issue regarding the volume probe is more easy scan with high BMI patients because less pressure is required from the operator when using a volume transducer. It is of major importance the proper way of holding and moving the transducer. One should avoid working with a volume probe without stable support. You can use the hand for the support, forearm or elbow. I will demonstrate the way of holding and moving the transducer by me and my coworkers. We place the hand first, afterwards the transducer, and we move it together. And this guarantees stability on the patient's abdomen. After these very basic tips regarding the probe, I will move to the image optimization. When performing any ultrasound scan, one must be conscious that information displayed on the monitor in 40% consists of noise. In the past, examiners got used to the presence of that noise and took it as a constant element of ultrasound imaging. Nowadays, thanks to algorithms that improve signal-to-noise ratio, it is possible to eliminate most of the speckles and improve by that tissue differentiation. These are default presets that use some of these functions, but they are indicated to an average patient who in fact does not exist. This is why operators should learn the basics of image optimization. Let's try to improve my imaging of fetal trunk, and we'll start from fundamental settings, step by step. This is the image obtained with the lowest native frequency levels of RAB 428 MHz transducer. I will store it that later we'll be able to compare its quality with the final product. I'm increasing frequency to the highest available levels. There is some improvement, but still more effort is needed. Now I have activated harmonic imaging. This modality enhances tissue differentiation but does not eliminate speckles. Harmonics has 3 frequency ranges. This is harmonics mid, harmonics low, and harmonics high. In the first and second trimester in normal BMI patients, high harmonics level is advocated. One can suggest reducing B-mode gain at this step, but this will only darken both signal and noise, so I will not do it. In the Voluson Signature series, HD zoom function is available, which enhances both spatial and temporal resolution. Let's try if it helps. I'll bring the box of HD zoom over the fetal heart area. Now the HD zoom is activated. Resolution is improved, but still much noise is seen. Next, I will activate SRI, the option that detects noise and eliminates it together with qualifying borders. So let's see how it goes. SRI, together with harmonic imaging, can be presented in the split image that you can see on your left, the harmonic imaging, but on your right, harmonic imaging together with speckle reduction. You see much motion at the moment. We wait until the fetus is more quiet and see the difference now. It's very, very clear. So speckles are eliminated. We can increase some levels of speckle reduction. This is the level number 5. And I see that the borders are much clearer. Another advanced image enhancing filter is cross-beam compounding, which is based on angulated beam transmission. Let's try to activate this function. I will come back to Zoom. And now I will go for cross-beam. Now, my imaging is based on combination of 3 most important image quality improving options: harmonics, speckle reduction, and cross-beam compounding. See that the tissue differentiation is much, much clearer in comparison with a native image that we had at the beginning. At this point, I need to emphasize once again how important is supported holding and moving of the transducer. You need support. When such advanced technology is used, operators should avoid fast and uncontrolled movements of the transducer. What can cause that imaging is less clear.